Slotting is the act of trying to determine which products should be in your locations and slots in your warehouse. It's also making sure that the slots you have enough product capacity to meet expected demand. It's usually done infrequently, if at all. A person, usually one or two, or a team of engineers, tries to determine new locations and matches for products. And then there's a physical move of those products and swaps or changes throughout the warehouse. For most warehouses, this happens once or twice a year, if ever. Some are doing it much more frequently, but generally that's the kind of status quo. Essentially, what we want to do is take the right data and bring it all together and combine it with IoT data. We use all those together and create a machine learning model. When looking at the machine learning versus the typical engineered slotting approach, or even just extending past slotting to workforce planning and other techniques, the engineered approach is great, but it can be costly and it can be manual and static. If things change, you're looking at reactive and historical data, and it's hard to keep up with the ever-changing DC. The rules engines can be brittle because as you add more rules, you start to contradict each other. And again, you can't react to simple changes. Conversely, the machine learning approach is all built with the idea of adaptability and reinforcement learning built into it. Some of these things are things you simply cannot do without machine learning. Besides trivial problems, specific coding instructions can become impossible and contradictory, and you really need to build in feedback loops into your models to be able to sustain over changes. So what do we need to do this? So first thing, we start with a warehouse map. We also connect to a data source. So most commonly, that'll be a WMS. Could be an ERP. And we also create a method just to do simple file uploads. The idea here is power and simplicity combined. We want to make this a super easy UI to use and leverage. And we want to differentiate from some of the more complex packages that require an industrial engineer to be able to run. You simply have to hit the request button and the system asks you for a number of recommendations. The idea here is towards the end of a shift, my replan guys are all wrapped up. So I have time for, say, 10 moves. Instead of doing that cleaning, maybe they can do those 10 moves. I can decide to make them independent or dependent and click request, and those will spit those out. Then the system will work for a second and then spit out some replan recommendations from the cloud. This is a full web-based UI. You can see the slot and SKUs here and just very simply say from slot 1, this product, the air filter for Kawasaki, should move over to slot 2. The reason code for that, this will result in a replenishment cost reduction. This likely means that this product that's getting moved to the front is being picked much more often, and it needs to go in a bigger slot because we're replenishing it too often. We calculate a reslot cost. The end goal is to spit out an ROI. So if I execute this move, I will make my money back in 4 days. You can have other reslot reasons, like a product affinity that, like I mentioned earlier, that's one that is coming up much more often and is one that's really hard to kind of calculate with Excel or any kind of simple product velocity based module. In addition to that, we generate heat maps. We can look at a few different metrics and color palettes. So here I'm looking at picks on a uniform distribution, and I can see my blades area here is really hot, but I expect that. That's what we sell the most of, and those are my optimum slots, so that's fine. I see some red way back here in the top of the warehouse. I might want to think about moving those products to a more optimum slot if possible. And I can look at different metrics as well. So here I'm looking at replan visits. I can look at different distributions. So if I want to see rapid changes, I can look at the logarithmic distribution and other configurations there. We do allow you to do what if recommendations. So if I know a product's coming in, I upload a forecast and I want to see if it makes sense to move it to the front or move it to an optimal slot. I can ask the system, is there a better slot for this product? What would happen if I did this swap? Another thing very important as we talk about that continuous optimization is providing user feedback to the model. So if I reject a recommendation, for instance, I can give a reason for that recommendation, and the AI engine will incorporate that feedback. Most simple example is I get a new SKU in, product master says it's one size. When the user goes to try to do the swap, it doesn't work. So we reject that recommendation, and now the AI engine incorporates that and says, hey, maybe this product size is wrong. I won't recommend that type of slot again. We can also implement custom columns and show things like current stock levels. So you might want to wait till a slot goes down to 0 before you make a move, makes the move cheaper, whether there's any orders allocated against a slot, things like that. Whatever you can dream of that makes sense, we can implement that as a custom column for your client version.